So we're into our final unit, all right, of the semester. We're going to, this is chapter 6 of the text, and we're going to look at solving or proving trigonometric identities. Now, there are some prerequisite skills that you should already possess or that will help you be successful in chapter 6. The purpose of this video is not to go through all of these prerequisite skills. Rather, we're going to just, this video will only look at how to prove identities. I will kind of flash through these, all right? So you will need to know how to factor, so simple trinomials, difference of squares, trinomial decomposition or hard trinomials, okay? All of these will be helpful. You should know how to simplify expressions, okay? So I factored here, took out a common factor here, and if there's a factor in the numerator and denominator that's the same, okay, so the cos theta plus 1 and the cos theta plus 1, they can divide away, or I can cancel those. And I have a tan squared theta divided by a tangent theta. That would just leave a tangent theta in the numerator. So I have a tangent theta times cosine theta minus 1. Should also know how to add and subtract fractions, or finding common denominators to do that. And then perhaps simplifying as you go through. These are some prerequisite skills that you should already possess. If you have any questions about those, you can fire me a message in the Teams app. The trig identities, okay, these are things you should know. Sine theta is the reciprocal of cosecant and vice versa. Cosecant is the reciprocal of sine. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. Quotient identities, tangent theta is equal to the opposite over adjacent. If you think back to chapter 4 when we were talking in terms of our y value divided by our x value, and we also knew that sine theta, or we made a connection that sine theta represented the y coordinate, cosine theta represented the x coordinate. So we can get tangent theta equal to sine theta over cosine theta. Cotangent theta is equal to x over y, or cosine over sine. Again, that comes from our knowledge in chapter 4. These are the Pythagorean identities. Okay, that is how they are developed or derived. Don't really want to get into that in this video as well. I just want to show you what they look like. These are the Pythagorean identities. Okay, and these are other forms. So sine squared plus cos squared equals 1 could also be written as sine squared equals 1 minus cos squared. So all I did was I left the sine squared on the left, I subtracted cos squared from both sides, or I took the positive cos squared theta and drug it across the equal sign, made it a negative cos squared theta. Similarly, you could do the same thing with cos squared theta if you wanted to isolate it, subtract sine squared from both sides, and you'd get this. I did show this, okay, just next to the tangent theta equals sine over cosine. If I square the left, I'd have to square the right, so squaring the right would make this a sine squared and this a cos squared. You could do the same thing for cos squared theta over sine squared theta, and so on. And the same thing with the reciprocal ratios. Notice when I squared the left, cosecant squared theta became, or sorry, cosecant to the power of 2 became cosecant squared theta. If I square the left, I also have to square the right, as I said. But when you square a 1, it stays a 1. 1 squared is just 1. Sine to the power of 2 is sine squared theta. And that would work for all of these. Now, these are things you must know. All right, I'm going to add a few in the coming days. We'll look at double angle identities and sum and difference identities. You'll add those to your list, but these are things that you should know that will help you have success in this unit. I would suggest by when you start out, have this in front of you, maybe print this off and look at these as you're going, because for starters, we're going to just do some direct substitution. So I'll be replacing one thing with another and trying to prove the left-hand side is equal to the right-hand side. So these are strategies, not rules. Strategies for proving identities. Work the most complex side and simplify it so it has the same form as the simpler side. And methods used in simplifying are direct substitution, factoring, finding common denominators, multiplying by conjugates, and so on. And I've added a little bullet here. I like to start out like this. I find this is a helpful strategy. Now, the truth is this. There is no one way of solving or proving the left-hand side equals the right-hand side. Okay? You might do it a little different than I do it, or someone might do it different than you do it. It doesn't matter as long as in the end the left and right are equal. I suggest saying that sine and cosine are the good guys, so to speak, so as much as possible we'll leave those alone. And then the other trig ratios, tangent, cosecant, and secant, and cotangent, we're going to change those. We can use these, like all of these can be expressed in terms of sines and cosines. Tangent is really sine theta over cosine theta, if we know our quotient identity. Cosecant, that's a reciprocal identity, 1 over sine theta. Secant theta, that is a reciprocal identity. I could use the 1 over cosine theta. And cotangent, I could use the quotient identity, cosine theta over sine theta. These actually have a reciprocal form as well. I could use 1 over cotangent, still a bad guy. Cotangent is 1 over tangent, which doesn't really help me out because I'm still expressing it with a bad guy. So all of the trig ratios can be expressed in terms of sine or cosine. So if you're wondering where that came from, tan theta replacing with sine over cosine, look no further than right here. And cotangent, 1 over cosine over sine, look right here. The cosecant theta, I said was 1 over sine, well that rule is there. The secant theta is 1 over cosine, that rule or that equation is right here. So let's look at how to solve these. So in the first one, I like to just divide my page into the left side and right side. And remember, as much as possible, we said we'd leave the sine theta or the sine x's and the cosine x's alone. That means I can manipulate this guy and I can manipulate this guy. Tangent theta is equal to sine over cosine. So I just replaced that with sine over cosine. I'm dividing by sine x. Now, you might ask, well, why did I use sine over cosine as opposed to 1 over cotangent? All right? Well, the reason I did that is because there's no cotangents on the right-hand side, or there's no cotangents to work with on the left-hand side that I could simplify. All right? So when you do something, when you do direct substitution, do it with a purpose, all right, or with an end goal in mind. Secant x, all right, I want to change that to 1 over cosine x. And the reason I'm going to get into that is because, well, I have a cosine x on the left, and that's my goal, is to prove the left and right are equal. Now this just becomes a simple matter of how do we divide when we're working with fractions. Well, dividing by sine x would be the same thing as multiplying by the reciprocal. Well, what's the reciprocal of sine x? It would be 1 over sine x. And now, if you did top by top, you'd get sine x, okay? Sine x times 1 is sine x. Cos x times sine x, you just stick those together, sine x, cos x. And these guys will divide away, and I'll be left with 1 over cos x on the left, and I do not have to go any further. Okay, that's what it says on the right. You didn't have to show this line right here. We could have just divided those away in that step right there. But remember, the goal, the only thing you're trying to do in this section is prove the left-hand side equals the right-hand side. So in the end, it should say the same thing on the left as it says on the right. Simple one here, okay? Cosine theta, secant theta, 1. All right, well, secant theta, that's the guy that I want to change. He's a bad guy, so to speak. I'll leave the cosine theta alone. I'm going to multiply by, well, secant theta, if I look back here at my rule sheet, secant theta is just 1 over cosine. And I'll multiply Cosine theta times 1 is cosine theta. 1 times cosine theta would be cosine theta. I'd have cosine theta over cosine theta, or I could just cross those off. I would have 1 on the left and 1 on the right. So again, just direct substitution. And I just want to point out that any changes I've made, this red tan x became sine x over cos x, and this secant x became 1 over cos x, and this secant theta became 1 over cos theta. That's all coming from this right here. So tangent x became sine x over cos x, and secant x became 1 over cos x, and secant theta became 1 over cos theta. All of those changes, all of these things are happening on this page that you need to know. All right, cotangent theta times sine theta equals cosine theta. Well, I've got two good guys, one on the left, one on the right, and I've got a bad guy on the left. So cotangent theta, again, some people might look at that sheet and immediately think to go 1 over tangent theta, but I don't have any tangent thetas anywhere on the left or right. So it's kind of a poor choice. With some work, however, you could manipulate that further and make it work. But the obvious or the more appropriate direct substitution to use in this case would be cotangent theta equals cosine theta over sine theta. That is a quotient identity, and we see it right here. Cotangent theta is equal to cosine over sine. So I'm just replacing that with cosine over sine. So times sine theta, I can slash these off, and I would be left with cosine theta on the left and right, and I can move on. Okay, so in the beginning, these are very basic, very easy. The job or the goal of this video is to kind of get yourself familiar with the trig identities. And trig identities are very helpful as we move along. Okay, they can be used to help solve a trig expression or a trig equation down the road. We can combine them with trig equations and use them to solve. All right, this one on the left, I've got this guy. That is definitely not what we want it to be. Okay, so sine x over cos x, I'm using the quotient identity. All right, over here it looks like I've got good guys, right? So I'll just work the left-hand side for a second. This would become cos x times the reciprocal. When I divide by a fraction, I multiply by the reciprocal. So this is cos x over sine x, and I end up with nothing cancels here. All right, those are both in the numerator, so cos x times cos x. Remember, I write that as cos squared x. You square the cos, not the argument. On the bottom, it's 1. There's a 1 under this cos x times this sine x. Gives me sine x. Now let's just evaluate where we're at here. What's good about the left and right-hand side? Okay, well, you might notice that the denominators are both sine x. That's good. So let's only focus on the numerator. Well, this right here, and it wouldn't matter if I changed the left side, if I changed the cos squared to this, or if I changed this to a cos squared. This right here is a Pythagorean identity. If I go back 1 minus sine squared x, and I look at this sheet over here, 1 minus sine squared x, that's this guy right here. 1 minus sine squared theta is equal to cos squared theta, so 1 minus sine squared x would be cos squared x. So I can replace the 1 minus sine squared x with a cos squared x, and I will have the equivalent form of the same thing on the left and right. So cos squared x over sine x, cos squared x over sine x. Now, it would be perfectly okay if someone changed the cos squared x to a 1 minus sine squared x. So this would also be correct. Cos squared x is 1 minus sine squared x over sine x. Same on the left and right. So I don't even have to change the right-hand side. You could delete or erase all of this. Fair? Here's a common mistake. Some people see this and they want to take that and cross this off. You cannot do that because this minus sign, if it was a plus sign too, it wouldn't work. That minus or plus sign is preventing that. Okay? So do not do that. If it just said sine squared x over sine x, sure. But if it's the 1 minus, you cannot do that, or the 1 plus, you cannot do that. One more, this one gets a little trickier. There's one extra step. So it's not just direct substitution involved in this. There's a little more to it. So we have sine y plus sine y times cotangent squared y equal to cosecant y. So this is through some mathematical manipulations and direct substitution, I can prove that the left-hand side equals the right-hand side. Now, what you may notice is that on the left-hand side, I actually have two terms. Sine y is one term. Sine y times cotangent squared y is a second term. I am going to factor out a sine y as a common factor. So I'll write down my common factor sine y. Both of these terms have a sine y. You can see it here and here. I would divide the first term by the common factor. So if I divide sine y by itself, I get a 1. Sine y divided by sine y is 1. Sine y cotangent squared y divided by sine y would give me a positive cotangent squared y. All right, still don't have that going on over here. Well, now I can kind of start manipulating things. This is a reciprocal identity. Cosecant y is equal to 1 over sine y. All right, I still don't have that here. This, however, is a Pythagorean identity. Okay, so I'm going to have sine y. I'm going to manipulate this in the brackets. And what can I change that to? 1 plus cotangent squared y. That's right here. Okay, 1 plus cotangent squared theta, or 1 plus cotangent squared y is equal to cosecant squared y. So I'm just going to replace that whole entire bracket with a cosecant squared y. And if you don't like using y's for the argument, you can always use thetas or x's, whatever you prefer. Still not there yet. Okay, keep in mind now this is still a bad guy. So it's that one that I should be looking at. Look, left side, I've got this sine y. I don't want to manipulate him. Over here, I've got the 1 over sine y. Don't want to manipulate it. Okay, this can go from 1 plus cotangent squared y to cosecant squared y using a Pythagorean identity. But now it can also go to a 1 over sine squared y if I use my reciprocal identities. Cosecant squared y is 1 over sine squared y, or cosecant squared theta is 1 over sine squared theta. There it is. And now it's just a matter of multiplying. So sine y times 1 would give me sine y. 1, that's under the sine y, times sine squared y would give me sine squared y. And now I can cancel. Because there's no 1 minus, there's nothing, that's just this one term divided by this one term on the bottom. I would be left with 1 over sine y on the left and on the right. The left and right hand side are now equal, are now equivalent. I have proved this identity. And as we get going, we'll check out some more moves. All right, it'll get a little more complex, but you can try these questions for homework. They're fairly straightforward, mostly just direct substitution. What you need to do is study, okay, so do those for homework, but make sure you're looking at this sheet to help you through it.